Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening, Madam Sabrina, because I'm doing this video at evening. My name is Usman Abdullah and I'm a member of group number 6. I would like to present to you my part, which is question number 1, identifying TCAS system and the components and the version of the system. So, TCAS is a system that whipped on aircraft to identify the location of the aircraft and track the progress of the aircraft with the transponder or transmitter responder devices. The goal of TCAS is to prevent a mid-air collision between airplanes that operate in the same airspace by warning pilots of transponder-equipped aircraft that might present collision threat. Thank you. And for the second component of TCAS, which is antennas. The antennas used by TCAS include a directional antenna that is mounted on the top of the aircraft and either an omnidirectional or a directional antenna mounted on the bottom of the aircraft. Most installations use the potential directional antenna on the bottom of the aircraft in addition to the two TCAS antennas. Two antennas are also required for the Mode S transponder. These antennas enable the Mode S transponder to receive interrogations at 1030 MHz and reply to the received interrogations at 1090 MHz. And for the third component of TCAS, which is the cockpit presentation, the TCAS interface with the pilots is provided by two displays, the traffic display and the resolution advisory display. Alright, here we go again. Now I'm going for TCAS components. Alright, so TCAS has three components: computer unit, antennas, and cockpit presentation. For computer unit, performance aerospace civilians intruder tracking, its own aircraft altitude tracking, threat detection, resolution advisory, maneuver determination and selection, and generation of advisories. The TCAS processor uses pressure altitude, radar altitude, and discrete aircraft status input from its own aircraft to control the collision avoidance logic parameter that determine the protection volume around the TCAS aircraft.
Assalamualaikum and hello my friend. Today's question is another really important one. Matt, can you explain the operation of a TCAS? This is a vital topic, especially if you want to become a pilot, and you will be dealing it a lot. In 2002, a tragic event happened in a commercial aviation history. Two airplanes crashed in a mid-air over Überlingen, a city close to a lake Constance in southern Germany. A Boeing 757 and a Russian Tupolev were on a collision course when a TCAS of both planes kicked in, and the Tupolev pilot gave a false input because of they listened to an air traffic order, and a few seconds later both airplanes crashed in a mid-air. Aircraft equipped with TCAS send out and receive radio signals several times per second over two frequencies. Signal received in 1.03 GHz radio frequency from the transponders aboard other aircraft provide a constantly changing 3D map of the traffic picture, which allows TCAS to perceive and react to the target threats. At the same time, TCAS send out a signal over 1.09 GHz frequency that can be received and interpreted by others nearby TCAS equipped aircraft. So, the operation of the TCAS are all commercial aircraft have to be fitted with a Mode Sierra transponder. The transponders send out a signal showing that aircraft position, altitude, or flight level, and current vertical speed. The TCAS scans the airspace around the aircraft for other aircraft fitted with such transponder at a 40 miles radius horizontally and 9,900 feet upward and downwards vertically. Therefore, the TCAS has two antennas fitted, one at the top of the fuselage and one at the bottom. So the antenna are on a constant lookout for transponder of intruders, because from the transponder signal the TCAS determines for each intruder its relative bearing, its range, and closure rates, its relative altitude if available. Why do I say altitude available is because some smaller aircraft only have mode alpha transponder.
Assalamu alaikum, this is Ammar. In my part of today's video, I'm gonna present the answer for question 3, and for that I'll be explaining and interpreting the information displayed in the cockpit that involves TCAS system. Now let's have a look on the indications presented to the crew in the cockpit. Basically, the system works on the secondary radar principle using the normal transponder's frequencies of 1030 and 1090 MHz, and it can deal with numerous threats at the same time. So any aircraft in the general area, let's say more than 1,000 feet away from a given aircraft, is not considered as a threat, and it will be presented on the navigation display as a shape of unfilled diamond, and it also gives the altitude information of that aircraft. For example, -1 if it's 1,000 feet below, and +2 if it's 2,000 feet above. Okay, now if that aircraft is getting a little bit closer, within a 6 nautical mile and within 1,000 feet away, then it will become approximate traffic, so that unfilled diamond will fill up and become a white diamond with its altitude and heading information. Now, if that aircraft is getting very close and start to come inside of about 850 feet, then a traffic advisory will be showed, and that traffic advisory is both that the filled diamond will become an amber circle instead, and it will also give an oral warning in the cockpit saying
Traffic, 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 traffic.
And it will also assist the pilot in the visual search for the intruder aircraft and to prepare him for a potential RA. So now if that aircraft is getting very close, within 25 seconds away from the given aircraft, then it's considered as a serious threat. So the resolution advisory will come in both. The amber dot will become a red trapezoid on the primary flight display, and an oral warning will tell the pilot what to do.
Climb, climb.
In this case, mode S will be activated to tell the opposite aircraft to do the opposite action. So if one aircraft is getting the order to climb up, the other aircraft will be ordered to descend. That's all from me, and now let's move to the last question.
Last but not least, I Divyashri from Group 6 will be presenting about question number 4, which is causes of accident and also suggestions of solutions. Based on the investigation that took place after the crash, it was said that there was not only one but several causes that led to the crash. So I will be briefly explaining about the causes that led to the crash. First of all, the management and the quality assurance of the air navigation service company did not ensure that during the night all open workstations were continuously staffed with enough controllers. This means that during the incident took place, there was only one sky guide controller in the workstation while the other one retired for rest. This one sky guide controller was required to monitor two frequencies and two radar scopes at the same time. On one frequency, he was guiding one traffic for an approach into Flight Rate 7, and on another frequency he had to control 4 aircrafts. Among the 4 aircraft was Baskiran Flight 2937 and also DHL 611. This controller had divided attention and could only deal with one frequency and screen at a time. Normally, procedure required a conflict detecting system to be operational while only one controller is working. However, due to maintenance taking place, this was disabled. Besides that, from 11:25 to 11:33, the controller tried several times to establish a contact with the Flight Rate 7 by phone. Due to working on telephone net of SkyGuide, the controller was unable to reach the Flight Rate 7. Unfortunately, the backup phone system was also not operational due to software failure that was not detected. This means that the controller has wasted a significant amount of time trying to contact the local ATC German unit about another aircraft. Furthermore, the maintenance work also meant that the radar system was operating in a downgrade mode, which was less responsive and also accurate. Therefore, the imminent separation infringement was not noticed by the ATC on time. The instruction for the Baskiran flight to descend was given at a time when the prescribed separation to the DHL 611 could not be ensured anymore. Last but not least, it was said that the Baskiran crew, following the ATC instruction to descend and continue to do so even after the TCAS advised them to climb, is also a major factor of the crash. This maneuver was performed contrary to the generated TCAS RA. Now, to the suggestions of solutions, it is best for the management and the quality assurance of the air navigation and service company to make sure that there is always staff in their workstation during all hours to avoid any accidents to happen. Moreover, the air navigation service company should ensure that if there is any maintenance needed to be done to their system, it needs to be done as soon as possible in order to avoid inconvenience and also to provide better service for the air traffic control so that mid-air collisions can be avoided.